Hello and welcome everyone to another session on Datahour. We are thrilled to be here with you guys this evening with a full action-packed learning. I am Badri, part of the data science team at Analytics Vidhya. For those who have joined for the first time, here's a brief introduction of Datahour Testing Change. The Datahour is a series of webinars conducted by Analytics Vidhya and led by top industry experts. It is a fun way to understand concepts of data science and AI from the leading players in the industry. Besides Datahour, we also offer blogs, hackathons, and courses to our community members. We can explore our latest agentic AI pioneer program, a specially curated course designed to help you master AI agents. AI agents are intelligent systems that can autonomously perform tasks, make decisions, and adapt to changing environments. And I will paste the link in the chat in 2 minutes. Now on to our session today, which is best practices for building successful LLM application. In this talk, the session we will explore advanced prompt engineering techniques, strategic decision-making frameworks, and essential best practices derived from real-world experience. You will learn how to select the right model for your needs, enhance your prompt engineering skills, and boost performance capabilities with RAG and or fine tuning. Moreover, the talk would equip you with frameworks for planning LLM projects and strategies for navigating performance optimization as well. Before we kick things off, here's the quick recap of housekeeping items. We are recording the session and the recording will be available on our events page. I will paste the link of the event page as well in the chat. And the recording will be available within 2 days. We will share the feedback pool at the end of the session. You are all requested to fill that. And as we navigate through the content, we will be sharing useful resources and links in the chat for your reference as well. Now on to our speaker. Our speaker for this data session is Bhavul Gauri with us. And Bhavul is a senior ML engineer at Meta AI, spearheading generative AI initiatives through his works with large language models and latent diffusion models. Prior to this, he has contributed to building foundational model for enhancing reels and video recommendations at Meta. Before joining Meta, Bhavul served as a research scientist tech lead at Zephyr, now part of Samsung, where he led applied NLP research efforts. His passion for AI extends beyond his professional role. And thank you guys for your patience. Now over to you.
Thanks, Badri. Should I begin? Can I share my screen?
Yeah, you can go ahead. Yeah.
All right. Thank you, guys. Just give me a moment. I'll just share my screen. All right. Is the screen visible to everyone?
Yeah, it's useful.
All right, cool, guys. Welcome to the talk. First of all, thanks to Analytics Vidya and Yashna and Badri for reaching out, organizing this all. I'm very happy to do this talk. And just before, the whole talk's going to be about how do you think about doing LLM projects in a successful way? What are all the things you should be thinking about? What are the industry-driven insights that you can utilize from the last 1 or 2 years that I've been working in the space, I've been consulting in the space. As for me, let's start with me as to why am I even relevant for doing this sort of a talk. So I'm a senior machine learning engineer in a GenAI team at Meta, specifically monetization GenAI. As for the work that I am directly involved with, I work on this kind of a product where basically we work with changing some aspects of the advertisements on Meta products, whether that's on Facebook or Instagram. We do generation with text, we do background generation. Background generation is the part where I'm most involved. And essentially, we pick up the product and we just completely replace the background. So when you're seeing the ads, you and your friend might see a different image for the same ad. And that's because we're doing personalized generation of background. And this has gotten enough media coverage in the last year as well. But because it's in the ad space, not everyone knows about it. I'm particularly leading two tracks here. One is all the LLM work, essentially, and that means prompt engineering, fine tuning, and RAG work. I'm also looking into fine tuning the image generation models. just for getting more performance out. In the past, I've worked with reels and video recommendations at Meta. I've been at Meta for about 3 years now. And besides all of this, I also love to contribute in open source research. So there's a research group which is completely distributed, completely online. It's an AI research group working on a bunch of different problems called Manifold. And you're free to join that. It already has 600 plus members. I'm a core team member there, and I work on multimodality and language modeling. So essentially working on some of the open source research as well. If anyone of you would want to connect with me offline after the talk, feel free to reach out to me on LinkedIn, Twitter. Those are the places I'm active. I'm also quite active on GitHub. So if you're up for any kind of collaboration or have any ideas, feel free to drop in my DMs. I'll spend some less time on my past. So in the past, I worked on some 0 to 1 problems in a startup called Zappa Media Labs. These were voice bots, recommendation system, and I've been in the space for about 8.5, 9 years now, mostly around NLP. So that's why I think LLMs, and I've been working with generative AI or basically language models since 2017 when they became popular. So probably I can offer some insights as to how I've seen the industry evolve. Okay, so moving on to objective of the talk. Before I kind of start with all the content of the talk, one thing I just want to, I think Badri also called this out. I would like to maybe take the questions at the end. So feel free to drop your questions in the chat or let the analytics with your team know what your questions are, and I'll be happy to answer them at the end of the talk. This will just make it more smoother, and sometimes some of the questions get answered automatically in future slides, so just makes it more efficient. As for the objective of the talk, what this talk will primarily cover is patterns that I've been observing or recommending or suggesting for LLM apps, whatever the best practices and pitfalls, and also like most of the patterns that are used very widely in prompt engineering, fine tuning, and RAG approaches, right? These are at the core of LLM apps. So I'll try to spend some more time covering these in more detail. What this would not cover is almost everything else. It will not dive deep into a particular tool. Like I'm not going to cover how you can distill your models or you prune your models or use mixed precision or anything of that sort, or any particular tool or library, like how you're going to fine tune using Hugging Face or Transformers library. I'm not going that deep in this talk. I'd be very happy to have a future talk or tutorial sessions around these kinds of topics. But this talk is more so when you're coming up with a new LLM project, or if you're already working on one, you can maybe align yourself with more of the best practices in town. So let's start with different kinds of LLM apps that we usually see, right? I've categorized them in 5. Maybe there's some exceptions I've left out, but for the most part, these are the buckets that I see, right? The first kind is chatbots and conversational agents. Now, these are, whenever you're seeing any sort of customer support bots, or you're seeing any scheduling bots, there are virtual friends, there are, any kind of coaches like mental health coach bots, all of these bots, which are essentially conversational agents. The whole requirement here is that you should be able to hold a conversation almost about anything relevant. And those are these kind. The second kind is copilots or app assistants, as how I call them. The whole idea here is that these are your AI enhancements being built into existing apps. For the most part, larger companies are doing this. So, for example, Copilot is being added to all the Office apps, to even Windows operating system, or any kind of any kind of AI assistant that is very specific to a certain task and certain domain or a certain app, that I would kind of consider as a co-pilot or app assistant. Then you have chat with data, where the essential use case is, you want to do some kind of a search, or you're trying to extract relevant piece out from a long piece of document. And this is being used in financial trading nowadays. This is being used in apps like Chat with PDF, and as well as search engines like Perplexity is doing it now. Nowadays, Google's doing it as well, and many other search engines. Then you have NLP tasks, right? LLM apps this is probably the most used and most trending use case. While a lot of new startups would try to attack the first three use cases, I think if you're part of a company and your leads are thinking about, hey, how can we involve LLMs into our existing technology, existing tech stack? Most of the times, this is where you're going to get the most gains, and this is something you can directly apply. Most business problems would deal with sentiment classification, name entity recognition, data extraction, where you're converting from unstructured to structured data. And all of these cases essentially are classical NLP tasks. In the past, we used to have separate models for each of them, or we would fine tune specific language models or RNNs, LSTMs, word embedding based models for each of them. Nowadays, LLMs can a lot of times be a single model to solve most of these cases, right? So it becomes like a single weapon to attack all of the problems. And the last one is autonomous agents. I think these are the most complex ones, but these are also the coolest and the most state-of-the-art applications you'll be seeing around. I'll start with a smaller one, auto-eval. Auto-eval is basically the bucket of AI applications where you're seeing LLM take over a human's job in some capacity. It's either doing a complete evaluation for a certain process, or it's completely doing some data analysis, or it's completely doing some annotation work. So essentially, you're replacing some humans with some LLM, multiple LLMs a lot of times, or at least one LLM, right? And it's been asked to do an entire piece of work essentially. You also get to do this with multiple LLMs, which tends to be called multi-agent setup. Agents can not always be LLM. These can also be non-LLM pieces, like you might be calling a database, and that could be considered part of a multi-agent setup. And then you can have anything that is trying to build an entire workflow, right? There were these sort of news that are floating around where people just ended up building a LLM and asking it that you're given this amount of money. These are my AWS credentials. Try to make more money for me. And what it's trying to do there is do a lot of planning and then execution and then evaluation and then recursively keep on improving like this. And that's where you're trying to build some sort of workflow, right? Now, the reason I was trying to point these all out is that the requirements differ, right? And it's very crucial to understand that if the requirements are differing, then you might want to have a different path to your LLM app, right? So if you're falling more in the chatbots space, you need to think about, let's say it's a virtual friend that you're building, right? Then memory requirement is a big piece for you, right? You should be able to handle a long context or fetch the right information from an existing database somewhere. If your virtual friend or AI friend cannot remember who you are or what you do or what you had told like a month ago, then there's a problem, right? While in other cases, for example, for example, with let's say NLP tasks, memory is not such a big issue, right? In most cases, it's just accuracy that you're focusing on. So all you want is high precision. Maybe if you're going global, you want to do multilingual handling, right? Some of the times the data set might not be in a usual text language. It might be more discretized. So maybe there's more pre-processing requirements, right? So there can be different requirements. In case of autonomous agents, you really can't build it with a very small LLM, right? In most cases, it will not do a good job. So in this case, the LLM is trying to do planning, it's trying to do evaluation of itself. So you require something that has good reasoning capabilities, good function calling capabilities. By function calling, if anyone's not aware, what I mean is LLMs are able to produce an output which looks like an API call to a function, and through that we're able to merge an LLM to call different tools, and that's called function calling capabilities. So as you see, right, different apps might have a different path. Here you require long context. For co-pilots or app assistants, you might have a lot of data from past usages of those apps, so which you can utilize to target specific customers. If a customer has a usual use case of drawing a certain kind of chart on Google Sheets or Excel, and they usually struggle with doing it, or they do it in like 15 steps, this is where a fine-tuned model can basically help reduce that and make it more effective for them. So this is where fine-tuning is more useful. Chat with data is where it's an obvious case of retrieval-augmented generation, because you're trying to fetch more data from an existing database or some PDF or some documents. For NLP tasks, most of the times prompting techniques are good enough. And only if you need to further enhance and just get to the best possible result, you can move to fine tuning or RAG, and we'll come to that later in the session. And then you have state-of-the-art GPTs, which you require in the last case, right? If you don't have a great enough model, you will probably struggle with autonomous agents. So that's what I was trying to basically ingest in everyone's mind, that what type of LLM app you're going for will essentially lead to the requirements. And those requirements are going to lead to what kind of path is possible for you. So it's not always that whenever you're starting on an LLM project, you should think that the first step would be prompt, then we'll do fine tuning, then we'll do RAG, or the other way around. It's not a linear path. It's very dependent upon where you're coming from. With that being said, let's start with how do we usually begin with any LLM project, right? The very basic parts of an LLM work or an LLM project is essentially you have some prompt, you feed it to an LLM, you get some output, and you evaluate that output, and the evaluation feeds back into improving your system instruction or your prompt template, right? I want to talk a little bit about these things because this is the most basic setup, and even in this, there are so many questions that you need to answer, right? What kind of prompts do you use? How would you iterate upon these prompts? How do you provide the most relevant context? Among LLM, like which LLM should we be using? There are so many LLMs out there. Then you have questions about what is an appropriate metric for evaluation? How are we sampling for data set? Who are the experts who are doing any kind of annotations here, right? And it's important to answer all of these questions before you move on to anything more complex. So let's start with something basic, right? When you're thinking about which LLM should you be using, the essential idea is that my suggestion is always to start with something basic, something small. Sorry, not something small. I mean, choose the best available LLMs out there. Do not think about latency or cost at this point, right? When you're just starting up, you want to understand, if I have a bad prompt, which you probably would at the beginning, what is the best I can get, right? So you want to establish a rapid iteration cycle, and to do rapid iteration cycle, initially for the first week, for the first month, it's okay to compromise on cost or latency and use the best models out there. So pick out the best closed source models, the Claudes, the GPT 4.0, and the likes of Llama 70B, 405B. Pick out the best models out there and try to evaluate how it's doing, and then choose whichever seems to be doing the best for your downstream task, right? So you have to first finalize which kind of model is doing better, because the different models do rank differently on how well they align with the output format, how well they align with the different kinds of downstream tasks, how well they reason. So there are different kinds of benchmarks that you might have. You might get a sense from benchmarks, but the best thing is just to evaluate multiple. Then let's come to evaluation, right? Evaluation is the other most important part. You want to make sure that you set up an evaluation cycle at the very beginning. Think of it always like, I like to suggest to everyone that think of it like you're working in the research space. And now this is a new problem you're targeting. And unless and until you have a benchmark out there, you will not be able to get a sense of any sort of improvements you're making, whether they are state of the art, how are they changing things. Do remember that even like smallest changes in prompts can completely change outputs sometimes. So it's very important to set up an evaluation path where you can initially just decide a metric. The metric should always be something related to downstream metric, right? So you're not measuring perplexity here or a usual NLP metric here. You're measuring how is it performing on your downstream task, right? If it's sentiment classification, you're measuring precision recall over there, for example, right? So you need to come up with a metric and then decide on a sample data set. Could be 100 examples to begin with. Something you can label within 1 or 2 days yourself if there's no one else in the team. And if there's a bigger team, get 1,000 examples. Try to be diverse, right? Build a first evaluation data set and try to then evaluate what is your baseline score, right? And your baseline score on the downstream map metric, not on any metric. Once you have this sort of a cycle set up, then you can start iterating on prompts, right? So start with a clear, concise prompts and how then try to give it more context, change the language of your prompts. So that's the basic setup of how you should be starting. Um, Generally, the best practices, as I just was mentioning, for prompting, leverage the prompt engineering techniques without getting into RAG or fine tuning. For evaluation, design the downstream app metrics, sample and label a small evaluation dataset, and set up an evaluation pipeline. And the modelers just use the best available without concern for cost latency. In in 90% of the cases, this is fine, using the best one out there for beginning the project. Not saying you have to stick to it afterwards. But at the beginning, it's fine to do this. Then comes the second phase of LLM apps, right? So you've done some initial prompt engineering, you got maybe some improvements to your metrics. For the sake of the talk, let's say precision was your metric on a given downstream task. Let's say you got 10% improvements in the precision number. Now, what do you do after this, right? So there are a lot of people think about RAG and fine tuning being a linear path. So you go from prompt engineering to RAG, then to fine tuning. Instead of that, I always like this example, which I've actually taken from an OpenAI video, but they cover it really well. The whole idea is that you start with your prompt engineering always. So you start in this block. And then what is it that your app requires? Does it feel like it's missing context? Would adding more relevant context make it better? Is it basically requiring more up-to-date information? Is it requiring some information that you're not able to provide in context? If any of those is the answer, you want to go towards context optimization and you want to move towards a retrieval augmented generation or a RAG approach. On the other hand, let's say that is not the problem. Let's say the problem is more so that maybe your LLM is not adhering to a certain format or a certain language in its output. You're asking it to give you a JSON output, but it's missing out. It's adding random commas. It's hallucinating the structure of JSON. Or let's say it's doing well, but you want it to do slightly better, and you have enough data set of labeled data, right? Or user feedback data. In that case, you move towards LLM optimization, right? So that's how you always think about it, right? It's not always required that you need to do both, right? A lot of times, for a specific use case, you might just want to go towards one of them. And there is, however, a possibility that these two are additive approaches, and you could potentially get more wins with both of them. But these are also both RAG and fine tuning are also heavy investments in terms of bandwidth and in terms of complexity. So it's not always easy to do both in parallel, especially for smaller teams. So it's useful to proceed in a cautionary manner here. Then the last part is maybe using agents, right? The phase 3. I recommend this only when other approaches are insufficient. So you tried RAG, you tried fine tuning, you tried all kinds of prompt engineering techniques. You're just not getting the right kind of accuracy, precision, or right kind of metric movement, right? Or the other case is when the application that you're building is so complex that it cannot just be done with the existing techniques. It cannot just be done with a single LLM call in any capacity. Our LLMs are not at that level right now of reasoning, of math, of whatever be the case where they can do, let's say, 50 different steps together, right? So in those cases, it helps to have LLMs call different kinds of tools, or you append multiple LLM calls together, and then you can build a very complex system as you want. And this is what we usually call as agents or LLM chaining. And this does have a lot of pros around reasoning improvement and reasoning improvement on memory or precision. But it also have cons that you're going to use more capacity, you're going to use more compute because of more LLMs, and you're going to use a lot of resources as well, because it's not just the LLMs you're calling, you're building an entire system. There are probably more databases, caches, and whatnot in between. And you're probably calling external tools sometimes, or doing web searches. So there's a lot of capacity being used essentially. And every new component that you're adding to your system is another component that can fail, right? So it just makes it a lot more harder. I'll now move towards maybe covering the different prompt engineering techniques and patterns. And after that, we'll come to RAG, after which we'll come to fine tuning. Given that I've covered a little bit about how you should proceed with your projects, with the practices around how do you move with LLM projects, I think now let's go deeper into prompt engineering, right? What are the different techniques out there? I've listed 9 here, and I'll try to go through them in order. But there are probably a few more. And if you search archive, there'll be newer ones. So it's not exhaustive. This is basically covering everything that has started becoming common, right, in most industries, or most startups or companies in these days. You always start with something called zero shot. And zero shot is basically when you're just giving the LLM, hey, translate this sentence to me from German to English, right? So that is your instruction, and you just directly give it German sentence, and you ask it to translate it to English. That's a zero shot case, where you're directly just providing a guideline, and that guideline could be very long, which it is in most production use cases. But the whole idea is that you start with a direct guideline. Unlike that, few shot is where so this is, for example, another zero shot case, right? Where you're trying to directly give it the question and asking it the answer. One way of improving this is where you add uh, the answer part, and you already add that LLM should be starting with let's think step by step. This is maybe a variance of zero shot. I usually consider it as that. And it basically aligns LLMs to proceed with the path of decoding, which has higher reasoning abilities or slightly better reasoning abilities. So it's able to give you, because it's now decoding tokens step by step, it's able to give you a better answer a lot of times. Then you have few shot, right? And few shot, what you're doing is you're providing some examples already as context, that this is the question and this is the answer, this is the question, and then you give an answer, right? So and the answer is being given by the LLM. So you can go ahead with a few shot approach where you're starting giving more context to the LLM and increasing the context. It's essentially going a step towards the RAG, but it's still far away from exactly what is considered RAG nowadays. Then you have something called chain of thought. Chain of thought is again something that helps with better reasoning abilities. And what's happening with chain of thought, right? So in chain of thought, you're basically asking you're basically feeding the few shot prompt with specific step-by-step instructions, right? So you're making the model say that it cannot just say the answer is 11. It has to come up with an entire step-by-step computation and construct an output. And this again helps with reasoning abilities. The next is self-consistency. Think of it like asking 10 different people answer to a particular question. The majority voting usually is the right answer. So that's what you're doing with LLMs also. In LLM, there's a parameter called temperature when you're doing any kind of prediction or inference with LLMs. And you can vary that to have some randomization in it. So the whole idea is you give it the same prompt and you sample multiple outputs from LLMs, and then you just see what is the final answer that is most occurring, right? So that you consider as the final answer, and this again helps better than the usual chain of thought approach where you're just giving it once, right? But what you see here is a pattern emerging, right? Essentially what you're doing is now you're doing more inference time compute, right? Instead of calling language model once, you're calling language model maybe 10 times, 15 times, right? So every time what you'll see as a pattern emerge in industry right now is just how well can you, anytime you're adding more context or anytime you want better precision, you will be thinking about a trade-off of more inference time compute or either fine-tuning or RAG, right? So there is some kind of complexity you're adding, and this is one way of adding that complexity for better performance. The next one is tree of thoughts. This one could be in its own like a 15-minute talk or explanation. So I'll try to give you a high-level summary, but each of these is a paper essentially or an archive article. So it's worth having a look at the respective papers and understanding more deeply what they mean. But essentially in tree of thoughts, what's happening is, so we have looked at, usual prompting, chain of thought, self-consistency with chain of thought, where you're doing a majority vote. What you're trying to do now is with tree of thoughts, you're evaluating multiple possible solution paths, and you're backtracking when a solution path does not work. So it's not just one path anymore. You're trying to go through multiple paths and then aggregate them together to give you a final answer. So this further turns it into a tree because from each path you're doing multiple possible sampling, and you can keep doing this, and this can be a large tree, and it's again adding more inference time compute just for getting better reasoning, right? So think of it, I like to think of it as a mega chain of thought in a way, essentially. Then you have explicit instruction ending. This is a very simple approach, right? The whole idea is most of the models out there are using GPT kind of architecture. So generative pre-training, in which case you are primarily relying only on the decoder mod part of the transformer. And if that's the case, it's useful to, they're always trained with these kinds of special tokens, right? What is the end of the instruction, what is the start of the instruction, what is the end start of the header, and so on so forth. What was the assistant, what is the input, what is the user instruction. It's always useful if for the model that you're using to see how it was trained and then follow the same kind of instructions. So you reframe your zero shot prompt or few shot prompt in a similar way, right? So you define different blocks, and the initial guidelines could be called system instruction start, system instruction end, and then it could be user input. And that aligns better with the model and a lot of times can give some better outputs. More importantly, it's able to give slightly more safer output, so the model would not hallucinate too much. Then you have generated knowledge. The whole idea here is sometimes LLMs aren't that great at answering directly, and you may not be able to get the few short context always, which is relevant. So how about you use the same LLM and ask it something like, hey, for this question, can you generate a hypothetical answer, right? Or 3 hypothetical answers, right? And then those become your generated knowledge. And then what you do is you call LLM again with this knowledge as context. Now, it's possible that this generated knowledge has hallucinations, or has some errors. But how it still helps the LLM is because you're providing this context. It knows what kind of keywords it has to think about, and it has sometimes improved again on benchmarks, the LLM benchmarks essentially. So this is another thing that can be used. And then you have active prompt, which is trying to do something even more complex, where you have those chain of thought prompting, and after this, you pass it to LLM to do some uncertainty estimation. So you try to see, when you're sampling it multiple times, sampling the answer multiple times, how much is the disagreement in those multiple times, right? That decides your uncertainty. And once you get an uncertainty ranking, only the uncertain questions go through a human annotation setup. And for others, you try to automatically build the build the agreed answers, and then you can kind of keep on increasing your essentially your data set, which can be passed as context, and then you start using that, right? So it's a way to increase your chain of thought context essentially, and make it do better. This is especially useful because chain of thought required a lot of human annotation to write exactly those kind of steps, and that's not always available, especially for domain areas other than math, right? So it's useful to do that. I also encourage. I've added this to the slide. There is a prompt engineering website, which basically prompting guide, which has all the possible techniques, keeps getting updated. So worth going through these as a resource for any kind of updates as they happen. They'll probably get published here. All right. The next topic is more so some hacks that you can use, right? So I like to think of these as slightly orthogonal to the previous techniques, because these techniques that we just talked about, those are proper prompting techniques. They have slightly a longer lifespan, I would say. However, these hacks can generally make any of those prompts effective, right? The first and foremost is clarity and conciseness. So you always want to make sure that you're trying to say things clearly. There's nothing that when you pass your prompt to multiple humans, they don't find multiple meanings out of it, right? So it should not be subjective. Try to be as objective as possible. For example, if you're, let's say, working with a multimodal prompt, you're giving it an image, you cannot ask the LLM, hey, is this an appealing image or not? Am I looking beautiful in this image or not, right? Those are very subjective criteria. You should probably go ahead with asking, what kind of clothes am I wearing? Are the clothes that I'm wearing matching in their color tones, attending to the usual fashion styles? And that's how you're making it a bit more objective, right? Or you can ask, like, do these sunglasses, are these sunglasses big enough for my face or not? So now you're trying to be more objective, right? So you can be more objective and more clear, and that will always help for prompting improvements. So that should be the first and foremost goal for any prompting. And this is why I think it's very important to have a person who has good communication skills to be the prompt engineer, right, in the team. The other part is assigning a role. Lately, I feel this is not so effective anymore. It can still be effective, but what I'm seeing is there is this pattern in the industry that anytime a prompt engineering technique usually works well, people try to create new training data set and fine tune the LLMs, or just train new LLMs based on that, right? So now, um, generally at this point, with most of the open source and closed source optimal LLMs that are out there, state of the art LLMs that are out there, even if you don't provide a role, I think it does a decent job and will get you the correct answer. But this has been an effective technique in the past, so you can try to, when you're asking it to edit things, you can say you're a professional editor. When you're asking it to do some sort of translation, you can assign it a role that you're a translation agent. So it used to help to assign the LLM a role. And sometimes, there isn't a direct role, so you try to, for your downstream tasks, so you try to go with something which can be a good proxy, essentially. The next thing is breaking down the problem solving into steps, right? Uh, so this is different than chain of thought. Chain of thought, you're trying to break the answer into steps. Here my ask is that for any given prompt, you can try to, if it's asking the LLM to do multiple things, or if it's a slightly complex thing to figure out, can you break it down? Can you break it down into 3 steps? Can instead of asking like, hey, try to generate a prompt for stable diffusion for an anime series which contains a boy, you can maybe ask it to generate, hey, how would the prompt look like for an anime series? Now, second step is, can you further add a boy into this who looks exactly like this, and so on and so forth, right? So you break your problem and your prompt into multiple steps, and that always helps because LLMs are able to tackle multiple steps slightly better. One thing to one caveat here is that LLMs don't do great when you add too many steps. So there is a limit here. Essentially, right now with current LLMs, maybe it's around 4 to 5 to 6 steps, right? So you might want to experiment with that. But if you break it down like into 9 or 10 steps, there is a chance that something might start hallucinating in certain steps. So try to keep this consistent to fewer steps. Emotional prompts is my favorite. It's very simple. Um, if you really need LLM to answer, you can always say it's an emergency. If you don't do this, my grandmother will die. Or just add like 5 different exclamation marks stating that you cannot add now you cannot do any sort of different format other than this, right? So when you're trying to be more emotionally aggressive in your prompt, that does help apparently. So you can try doing that. If LLM is not following a certain instruction of your prompt, try to just say that, like, make sure that you repeat that in a positive tone, but add multiple exclamation marks there, or just add some kind of an emotional blackmailing sentence in the prompt. Self-reflection is where you're asking the LLM itself um, to judge the prompt that you have made. So you can start with providing the prompt with the question to the LM and just asking it for the answering this question, is this a good prompt? Or can you see any sort of ways of making this prompt more clear or concise or more effective for answering questions like these? Right. So something like that is self-reflection, and that is a technique which again you can use with all the most of previous techniques, and that should work. The last is avoid negative words. Again, this is a debatable thing, but negative words still do work with LLMs when you try it out. But positive words, just in my experience, seem to do better. So it's always better to have completely a positive prompt instead of saying, don't do this, don't do that. So try to avoid negative words where possible. With that, I'll now move into the next part. So that's all about the prompting techniques. The next part is retrieval augmented generation. What are you doing with retrieval augmented generation, right? So the whole idea is you're trying to ask question, but instead of directly getting passing that to LLM and getting an answer, you do a search with some kind of a knowledge base. And the search usually involves some kind of embedding similarity. So you turn this query into a text embedding, you do some nearest neighbor search through a vector database or any sort of nearest neighbor search tools, and you get relevant documents back. And then you pass those as the context. So what's happening now is you're giving your instruction to the LLM, but you're also giving very relevant context for past similar cases, right? It's the same as let's say a customer support agent. If when they're trying to solve a customer ticket, if they get a list of previous tickets which are of the same topic, they would probably know what to do, right? So LLMs kind of work in the same way. They are able to do a better job when context is needed. The other case is when this knowledge base keeps on increasing on a daily basis, and it's important to stay updated. You cannot keep fine-tuning your LLM every other day, right? It's a very expensive job. So that's where RAG approach helps as well. It feeds in the new information to the LLM. But that's a simpler version of RAG, right? What it actually ends up looking like is something like this, right? Where you have uh, too many different portions into it and too many failure points, right? So there is your knowledge base where you have documents which you directly cannot put in a database. You have to chunk them for getting more optimal performance, because large language models have an issue of losing context in the middle. So it's better to chunk things to be more precise. The other thing is you sometimes have to rewrite your query. You have to retrieve the right things. Maybe things are missing in the database. Maybe the retrieval logic is not great, so you don't get good results in the retrieval. You often re-rank it and consolidate it. Maybe that part is missing. So there can be a lot of different issues, including wrong format, or you were not able to extract the right knowledge. So there are what you're doing with the retrieval augmented generation is adding a lot of new steps into the system and a lot of new components into the system. So it's important to know beforehand that this is something you want to do, because it's not a small investment anymore. Um, let's look at the benefits and limitations, right? So benefits is it will be able to introduce new knowledge, which maybe your LLM by default did not contain. It will reduce hallucination, and you are able to provide extensive content, but context, right? But because you're providing extensive context, it also means tokens consumption has increased, which means costs will increase, right? Costs are also going to increase because you're trying to add so many components, right? The other thing it does not help with is LLMs will not start respecting a format because you're doing retrieval augmented generation always, right? So they might not start giving you answer in a new language or new formats. It doesn't really help with that. That's where fine tuning helps better. And it cannot meld a broader information about an entire field. Let's say we discover a new field of physics tomorrow. Um, in that hypothetical scenario, we cannot expect these open or closed source LLMs, which have been majorly trained on the internet. If that data does not exist in the internet, it's an entirely new field. You cannot expect RAG to completely solve that unless RAG is basically working on doing something which underlying LLMs could also do, right? So embedding of chunks does not make LLM understand the entire field, right? So if there is certain kinds of logic that used to work, let's say a certain country had a way of doing taxes, and that has no information on the internet in an open source way, then possibly RAG might not do best there, even if you're passing the right relevant context. LLMs might fail to do the right kind of reasoning, the right kind of computations. And there are some patterns emerging in retrieval augmented patterns generations as well. And we'll try to quickly go through one by one just to give a sense of what these are and why they exist. So re-ranking, fine-tuning embeddings. Right? Fine-tuning embeddings is simple, so I'll tackle that first. You remember how I showed that you're trying to embed the query using text embeddings and then do retrieval? Um, those embeddings, a lot of times we used off-the-shelf embeddings from different models. And for each LLM, I think you can Google up or do a perplexity search to find which could be recommended embeddings. But essentially, one way to do it better is that you can fine tune your embedding specifically for your knowledge base, right? And this will probably give it more focus on different words that matter more in your specific world or in your specific knowledge base. The other part is re-ranking. Re-rank is often important because you gave a query text and maybe your retrieval engine gave some results. But it's possible that for the given query, the relevance that the retrieval engine gave is not the best. So you have an LLM to do re-ranking where you're asking it, hey, this is the query. Can you re-rank the results? And it might re-rank them based on relevance score. and then you use the more relevant context. You also have hypothetical document embeddings. The whole idea here is similar as to what I spoke about in generated answers in prompting. Essentially, you ask the question and you ask LM to give you a hypothetical answer or multiple answers. And then that answer gets turned into retrieval augmented generation context, right? So that is used to search, to do the retrieval, and just do better relevant searching. Chunking is often useful because, you know, naively you would think that anything, when you're passing any context to LLM, you can keep on increasing that context as long as the LLM context window allows it, and LLM will be able to pick out a needle in a haystack, right? But that's not the case. LLMs actually struggle with finding content from the middle. They are good at finding content from the starting and the ending, much like humans do. But they often forget or don't pay enough attention to the middle. And there is a paper around this. So what happens with chunking is you're breaking down your existing knowledge base into smaller chunks, and you're only retrieving smaller chunks. And when you're doing that, you are making it more focused in retrieval, in generation, in the context, and that helps in retrieval augmented generation with its performance. The next is query writing. So query rewriting is often required because your users will not really be always asking clean queries. Like for example, here, essentially they wanted to just ask, where do the dolphins live, right? But the query that user asked, we have an essay due tomorrow, we have to write about an animal, I love penguins, so on and so forth, right? Very long query. And if you pass this entire query now to a vector database, just embed all of this information, it's probably not going to return the best results, right? Essentially, the query is about where do the dolphins live. So you want to maybe first rewrite the query so the retrieval components work better, and your retrieval, if your retrieval is better, your context would be better, your generation would be better. The other part is multi-query. So you often also have these kinds of cases where user might ask something that might require two different things, or it embeds two or multiple different retrieval queries within it. So in this case, it's helpful to split the query into multiple. So you use another LLM to rewrite the query, and you do one for 2020 financials, one for 2023 financials, and then have an aggregation at the end, right? So you'll see that there are different LLMs being added for re-ranking, for hypothetical document generation, for query rewriting, for multi-query, and you have a ton of LLMs now in the picture for retrieval augmented generation. The other part of the RAG systems is the evaluation mechanisms, right? So just the usual evaluation that we initially discussed of how is your downstream top line metric is not good enough anymore, right? Because now your system is more complex. It does not just have a single LLM. Now your system has retrieval components. It has and you have a database, you have a knowledge base. So it's important to do something. There is a framework for evaluation called RAGAS. It's an open source framework. You can even just copy the code and use it directly in your projects. But the whole idea here is that now you have four different entities: question that's coming from the user, answer that you have to generate, context that's coming from the knowledge base, and ground truth, which is your knowledge base, right? And you would be doing some, one of the things that you require is what is the precision of the context, right? So the context that's being fetched from retrieval, how useful or relevant is it to the question user has asked? The other thing about context is context recall. How many of the relevant knowledge base entries or documents or chunks were we able to fetch for the context, right? So both of those, measuring both of those becomes important, right? And it's not always easy to measure these, right? Because for a specific proprietary system, knowledge base, like you would basically require humans to annotate these things for each of them. Then you have the faithfulness, right? So faithfulness is given the context, how relevant is the answer to that, or how relevant is the context to the answer, how are they. And the last thing is what user wants, essentially. How relevant was the answer to what user asked, right? So there are now these four different axes for retrieval and generation that you need to think about from a metrics perspective when you're tackling retrieval augmented generation. The last thing I'll move to now is fine tuning. So fine tuning LLMs is you have what's the benefits and limitations, right? So the benefits are you're able to make LLM follow a certain kind of format or certain kind of language or certain kind of output structure. That's very easy to do with fine tuning. And often the primary use case actually for it. The other primary use case is or the equally primary use case is lower latency and cost, because often you can make a 7 billion or 13 billion model perform at the same level as a 70B model if you have some data to fine tune it, right? So you can use a smaller model. You don't have to write a long prompt, a chain of thought sort of prompt, or a rack kind of prompt. You don't have to do any of that, because when you're fine tuning it, you directly give it the user input and you directly give it the output you want in the right format, and you fine tune the model. And when you're doing that, it learns to always do the structure, and it learns to do precisely as well on your specific downstream task. And this helps in teaching complex instruction. Let's say your initial prompt was many different involves breaking down the problem into 10 steps. Now those 10 steps, you don't need to provide them in the prompt, and you can directly get an answer to them, right? So you're embedding that not embedding, but the knowledge has been there in the LLMs, but you're just making it more precise by moving the LLM distribution into and its weights to that kind of a distribution. It's always any kind of fine tuning is always just emphasizing existing knowledge. So that's very, very important to understand, right? So uh, when you're doing any kind of fine tuning, it's um, you're making LLMs better at finding the right answers. But the LLM's capabilities of being able to produce those answers have to be there before fine tune, right? So if an LLM cannot do a good job at answering a certain question, or it does not have capabilities to answer a certain question, fine tuning may not be the best approach and may not give you the best results. In that case, you probably need a larger data set, and you might need to put it in pre-training. So that's something you want to do. From a limitations perspective, the biggest limitation is fine tuning is the slowest of the bunch. So you require the iteration speed is much slower because you are fine tuning a model. You can improve on this with some of the more optimizations that have come out in the last 1 year. But still, I think fine tuning requires building a data set, making sure the data set is clean, then doing fine tuning, monitoring metrics, doing hyperparameter search. There's so many different things that could go wrong that it does have a slower iteration speed. The other challenge that fine tuning struggles with is catastrophic forgetting. If you give it too many examples of a certain kind, LLMs will stop behaving well generally. So it might be able to answer anything that was part of the training set or something similar to it, but it'll be really bad and hallucinate or just give bad responses to anything else, which LLM was able to do before fine tuning. And this is one kind of overfitting. So overfitting can generally happen because you're training the model. The last thing is it's not super effective in incorporating new information, right? Which is the same thing as this. What are some of the patterns that I've seen? So the pattern that I've seen is you should start small. If you want to proceed with fine tuning and if it seems relevant to you, just start with a data set of 1,000 examples, right? Maybe even 500 if you want to just give it a try and build the pipelines first. But start with a small, very high quality, clean data set and get a sense of whether fine tuning is going to work for you or not, right? Uh, how do you evaluate that? Use human evaluation. Always do multi-annotator setup. So the same prompt or the same output is being annotated by 3 people or 5 people or maybe 9 people, some an odd number essentially. So you get a win rate there, right? And always see in a ranking way is the fine tuning doing a better job than your non-fine tuned model? If it is, that's when you start investing more in this, right? That's when you can go into different fine tuning strategies. You can think about, instead of doing supervised fine tuning, you can do preference fine tuning, you can do reinforcement learning based fine tuning, or you can invest more in just data set approaches, right? How can you increase the data set, make it better? So those are the usual patterns and best practices. Skip the slide. One more thing that I wanted to just point out was some best practices to adopt from software engineering. The biggest one being version control. Like, you want to always make sure that when you start on an LLM project, you are tracking every single change you're doing to prompt template, and you have an evaluation data set to start with, and you're versioning these as well, because you might keep on upgrading your evaluation data set every other week or so, right? Sometimes less so, but you might have a certain data set, right? And it's important because if you're splitting the work into multiple people, you don't want all of them to be evaluating on different data sets, which have different kinds of biases. The other is agile, right? Being agile. So once you set up initial evaluation, set up a pipeline to automatically test a new kind of prompt candidate, right? Prompt template or system instruction candidate. Do rapid cycles of iteration, which means like every 1 or 2 days you should be able to do an iteration on prompt system instruction and get something new out and see how that's performing, or learning, right, something from it. So prompt engineering is not something that requires a lot of days of work. The biggest learning to take back from today's slides is, however, to always pay attention to user interactions. Are they are they basically asking any questions that are multiple questions? Are they asking about something that's for which data is not available? Are they asking questions which require stronger reasoning skills, right? Each of these would either lead you towards better model, or a rewriter, or RAG, or something of the sort, right? So unless and until you have a pipeline to automatically sample, let's say 100 or 500 user requests and generations every week, you would not be improving your systems just theoretically. So that's the biggest thing you should be doing. The last thing I wanted to chat about was just the team skills and project planning, right? Because these three things that we covered at the heart of LLM projects, they all do require slightly different skills and different team size, right? For prompt engineering, you want somebody who is clear in their communication skills and who knows what LLMs are, what are the LLM APIs, what are the different LLMs out there, and what are their benchmarks essentially. However, for RAG, you want somebody who has worked a lot on data side, right? You want good data engineering skills. You want somebody who has in understanding of retrieval systems. You want somebody who's good at building complex integration of one component to another, and building just a more complex system in general. And this might be a stronger engineer that you require here, right? While for prompt engineering, a lot of times you may not even require an engineer, right? So, but you do require somebody with good, clear communication skills. On fine tuning front, you want somebody who has expertise with training models in the past, ideally language models or one of the generative models. And they need to be good at data preprocessing. So the expertise or the skills needed are quite different, right? And team size also differs. RAG is a much more complex setup, so you do require more people. While in fine tuning, you don't require too many people, but they need to be experts at doing some training or fine tuning in the past. You cannot hand it to literally a new person who's joined the job on the first day and expect it to work well. This is literally my second last slide. So we are almost out of time. I understand that, but some of the common pitfalls that everyone faces. The biggest one, people start building their systems and forget about how users are interacting. People also don't pay heed to biases in the data set. So sometimes LMs will start outputting personal information, sensitive data. So you want to make sure when you're providing any context, when you're building any sort of training data, fine tuning data or anything you're adding into the prompt that does not have any details which are non-anonymized. The other thing is just biases which come from the team developing it. If it's the same team, belongs to a certain region, there can be regional biases because a lot of LLM evaluation is subjective, and subjectivity is better attacked with people coming from different backgrounds and different places. So it's useful to have diverse annotation teams at least. The other thing is just red teaming safety. If your LLM application is such that a user can give a prompt, then always think about uh, there are a lot of jailbreaks out there. Most of the top LLMs would have tackled them, but you should check your LLMs as well, right? Your application should not be breaking with those jailbreaks, essentially. Yep, that is it. I will stop here and take any questions. There are two QR codes here. One, if you want to connect with me, discuss any ideas, any questions, any feedback, any consulting, I'm happy to do that. The other one's for these slides, so you can get access to the slides immediately. All right. I'll pass back to Badri. Badri, are there any questions?
Yeah,
I,
yeah, it's totally fine. Can we go ahead with Q&A? The session contains around 10 questions.
I think I can give another 10 to 15 minutes, so we can
Yeah, yeah,
probably go ahead with the Q&A. Yeah.
yeah.
Thanks. All right. Where are these questions?
In the Q&A section near chat,
1 second.
next to chat, next to participants. Are you able to find it?
Just a sec. I haven't done a webinar in some time. Just a sec. Let me try to.
Or
I'm
I
able
can
to
share
find
my
the
screen as well.
I'm able to find the chat.
Okay.
Um,
Or I can share my screen as well. You can just
oh,
answer.
that'll be, yeah, that'll be great. That'll be great. Thanks.
Yeah. Can you stop sharing the screen?
I'll stop sharing. Yes.
Yeah. Mm. Yeah. Is my screen visible?
Yes, yes. Let's go one by one. Okay. Which is the first one? Is self-consistency. So this is from Hemant Chaudhary. How do we get different outputs from the same input? What are we changing to get this? Good question. There are two parameters that you can try working with in almost all the LLMs. Even the closed source LLMs would, through APIs, give you access to these parameters. One is called temperature. The other one's called top K. I just because we have 10 questions, I'm not gonna specify the details of these two parameters, but try to have a look at temperature and top K, and those can let you sample different responses. They basically introduce randomization into the output. The second question is, we say there are another set of prompting techniques used for security testing, like a cyber team to see if any vulnerabilities, prompt injection adversary. Yes, actually, there is a whole field around just jailbreaking, red teaming. Red teaming is the keyword that gets used the most with LLMs. I haven't interacted much on that side, to be very honest, because most of the use cases that I've either consulted for or helped in Meta have all been somewhat like backend use cases. So there wasn't a lot of interactivity to the user. So haven't really had a chance to dive too much deep into this. but there is an entire red teaming forum. If you just search red teaming LLM forum, you'll find a forum around this, which with where you'll find different injection capabilities there are, and you can always search for papers on archive for this. Yeah, but there is active research going on, and with every new LLM, there are new jailbreaks that are found. There are new vulnerabilities that exist, both to find whatever content it was trained on, as well as just to understand the distribution of biases within the data. So there's a lot of work going on that front. If you connect with me offline, I think I can like if you reach out to me on LinkedIn or Twitter, I can also send you some resources offline. I have some knowledge on Python and machine learning. However, I'm new to deep learning and Gen AI. Is it possible to skip deep learning and learn Gen AI? Generative AI will most likely work with transformers in most cases. Transformers would depend upon neural networks. So my suggestion would be you can skip maybe some of the classical techniques if you want to, and maybe jump more into neural networks and start from there. Neural networks, then transformers, then generative AI work that has been going around either in vision, speech, text space, whichever space you'd like, right? But you cannot skip deep learning altogether, right? You can skip maybe SVM and some of the existing classical approaches. Maybe even you can skip on random forest tree-based approaches if you'd like to. Do you have some recommendations for query rewriting and multi-query prompts? Yes, it's like I can again. This is something for which Kinshuk, if you don't mind, just reach out to me on LinkedIn. I have some good resources, bookmarks around this, some articles, and some tools. There are tools, open source tools on GitHub around query rewriting as well. But generally, it's essentially another LM which is trying to break the current prompt. So you're basically writing another LLM prompt to either rewrite this one in a more clear way, or you're asking it to break it down if it has multiple steps. So with multi-query, you always apply it and you see if it outputs like a single instruction or multiple instructions, and then you accordingly process it. But feel free to reach out. I'll send you some articles around this. The other ones also regarding, would you recommend doing multi-query retrieval, combining context and giving it to the LLM, um, or giving the LLM a retriever function for LLM tool function? I would say try out both. This is on the edge of where it's hard to answer what would work for your use case without knowing the use case. So my suggestion would be a lot of LLM based um, applications, especially if you've gone to this phase, if you're trying to think about function calling versus multi-query retrieval, you can try out both and see what works better. If one of them is more complex, then you can stick to the easier one and see how far does it lead you. Best LM for data extraction. Uh, this would be very personal right now. I stick to either the Llama 3.2 models or the Claude Sonnet models. Those are the ones that I personally use for similar exercises. But yeah, I'll leave it up to you, whatever you. I don't know again the use case that you're going for here, but those are two good models for data extraction. Um, For fine tuning, one challenge we see is that requires lots of ongoing investments as not just one time, like measuring drift, when to fine tune again, data curation, TCO, yes, better models come out. So that's very, very true. And that's a very good question, actually. So I'll take a moment to answer this. Some of this was also not covered very well in the slides. All of these bits are important for fine tuning, especially measuring drift. How soon do you want to fine tune again? Generally, there isn't a strict guideline around this. It depends on the business use case. How soon does your data get stale, or do your models stop behaving appropriately for the user? What's important is to set up an evaluation pipeline and kind of get an answer through that. How soon are the models not good enough for the user, or for basically discovering new capabilities that your model is not able to answer properly. Data curation is like if you're trying to invest into fine tuning, it's never going to be a one-time thing. In the worst case or in the most pessimistic case, you would be doing fine tuning once in 6 months, once in 8 months. Otherwise, you might be doing it every other month or every few weeks. So it's important to set up also a continuous data annotation platform around this or some sort of a pipeline around this. And if you don't do that, you're basically not collecting right data. The way to always check when do you want to do fine tuning again is to see how much percentage of your answers are not relevant to the user. And if that introduces a certain capability that you want to add, you can add more data of that kind. And if it's mostly about the formatting and stuff, you can always just do synthetic data generation quickly and do another round of fine tuning. So it's more about like, does it require real data or synthetic data? If you can find a way to do synthetic data, a lot of teams are able to do fine tuning within a week and a half also, and get something out with quick fixes. Building an LLM from scratch is better or using available LLM? For 99% of people, using available LLM would be better because building from scratch is a huge investment. You would probably not be able to gather resources. If you really work for one of those companies or have enough grants to build your own LLM, even then, right, what is the motivation behind it? Unless you want to compete with the likes of the larger players in the space, or if you have a specifically targeted LLM you're building, let's say only working well on math, then maybe it makes sense as a research problem, but um, probably not a great business idea at this point unless you have a very specific goal. If LLM response is wrong, how can I add this type of input, corrected result into LLM? There are a few ways of doing this. The one way is actually around self-reflection, where you give it that this was a wrong answer. How can the prompt be like prompt template or system instruction be adjusted so the LLM answers better, and LLM would be able to a lot of times suggest you updates to your own prompting. The other way is put it up as a few short contexts to start with and see if that improves things. Thanks from Om Prakash. What are the best LM agents frameworks available? I would say LangChain, Llama Index, these are the ones on the open source side which are being used the most. So try to stick with them. They are pretty well contained, especially for anyone new trying them out. It's pretty well done. And if you find something missing, it's a good opportunity to be able to contribute to a large project right now in the open source space. Yeah. How can we improve our model to put an end to hallucinations after fine tuning? Um, Hallucinations can still happen after fine tuning. So one way you can, so this is where I think if you're getting hallucinations after RAG, you might want to do fine tuning. If you're getting hallucinations after fine tuning, you might want to do RAG. This is one such place where adding them together actually helps to reduce hallucinations. I don't know if there's a answer to reduce putting an end to hallucinations. LLMs by their nature are sampling tokens, output tokens, and there is a possibility that they would sample something bad. You can always do, there are approaches like what probably GPT-O1 is using. Like you can do a compute time inference, but that's very complex. I'll just summarize it. It tries to do a compute time inference and try to go through all different paths and figure out what is the best reasoning path. So that reduces hallucination, but only for certain kinds of problems. There isn't an easy answer to ending hallucinations once and for all. Then some question from Anonymous. I've done MSc Math, wanted to learn data science from one offline private institute, but my question is, should focus on data analysis to land in job? Because in current situation for fresher, opportunities are in data analyst and data scientist. Okay, got it. So I would suggest if you're getting more opportunities in data analyst roles, it's not bad to begin with. I've seen numerous transitions from data analyst to data scientist within my 9-year career. So you can always try that out. Yeah, it's not a bad place to start. Yeah, you will be able to switch within the company or to a different company. All right. I think that answers. One more question from Dino at the top is for self-consistency using the same LLM or different LLM, how it differs from using mixture of experts approach. Mixture of experts, like philosophically, it's very different than self-consistency. Self-consistency by its name is where you're trying to use the same LLM, right? So that's why there's a self in there. So you're not using a different LLM. All right, thank you guys. I think that's it. I would also have to drop off. Badri, thanks a lot for organizing this. Hopefully this was a helpful session. And
Yeah, it was very
if there's
interesting as well. Yeah, thanks a lot for the session. Thank you,
okay,
everyone.
have
See you
fun.
in the next data.
Thank you.
Bye bye.
Bye, guys.